Here is day 3 of Trig Identities, last day of section 5.1. Let's start off here with example 1. Take a trip back to 5th grade. And I want you guys to pause the video and complete this problem in as much detail as you can and how you would do it in 5th grade. And then unpause and come back to me. Okay, so at this moment you should have completed this problem, and if you recall, you are supposed to get common denominators when you guys are adding or subtracting fractions. So the lowest common denominator, what we used to say LCD, is going to be a 12. So what you're going to do is you had to force your denominators to have a denominator of 12 by multiplying by a factor that would lead to that denominator being a 12. So we're going to multiply by 4 in the numerator and the denominator on that first fraction, and we're going to multiply by 3 on the second fraction to the numerator and denominator. So we get 8 over 12 plus 3 12s. And now that we have common denominators, we are able to combine these fractions to therefore end up with one fraction of 11 12ths. So the method that you have done in this problem translates into our trig functions when simplifying. Okay? It still applies. Common denominators, adding and subtraction of rational numbers, even if they involve trig functions, it still applies. So notice here in part B, it also has two distinct denominators, just like it did over here in 3 and 4. Okay, so let's mimic what we did here on this side. We want our denominators to be the same. How did we get our 12? Well, we ended up in this particular problem, we had multiplied 3 times 4. All right, because they were both prime numbers, and the lowest multiple that they both shared was a 12. Over here, these are expressions. So our LCD in this problem is going to be the multiplication by each other. So we want cosine theta and sine theta to be our lowest common denominator. So we are going to take the first fraction and multiply it top and bottom by sine theta. Just like we did over here with the 4. And then we're going to do plus 1 over sine theta, and we're going to multiply it top and bottom by cosine theta. And in doing that, 1 times sine, we get cosine sine. We write them next to each other. You can't merge them, they're distinct, plus 1 times cosine, and we'll put them together. Now since we mentioned cosine here first and then sine, I'm going to flip these around. And we can do that because it's commutative. And now that we know that they have common denominators, let us combine by addition in this problem and put them over the common denominator of cosine sine. Okay. So notice how it parallels part A, even though they are involving trig functions. Okay, and this is our final answer. So 11 12 was our final answer here, and sine theta plus cosine theta all over cosine theta sine theta was our final answer there. Okay, so let us go on to the next one. Okay, again, we have two distinct denominators. So let's have you do this problem, and I want you guys to visualize these denominators having parentheses around them because they need to stay together. Okay, so go ahead and imitate what you did over here, but this time our denominators are 1 minus cosine theta for this fraction and 1 plus cosine theta for this fraction. So go ahead and pause your video, try to get as far as possible as you can with this problem, and then unpause and work it alongside with me. All right, thanks for coming back. Let's go ahead and do this. So we're going to write this fraction, and I am going to multiply it by 1 plus cosine theta, top and bottom. Let me put parentheses around this too. And then I'm going to bring down this fraction, and I'm going to multiply it top and bottom by the other denominator of the other fraction. Okay. All right. So now that we have the denominators being the same, okay, let's go ahead and put them all together. Well, the 1 has to multiply by both of these, and 1 times that will just remain 1 plus cosine theta. Okay, so that's gonna, you know what, let me just scoot that over a little bit because it needs to be long anyway. So 1 plus cosine theta over, and let's put the denominator 1 minus cosine theta and 1 plus cosine theta. I'm going to keep the denominators with parentheses, and then I'm going to do the same thing over here. The 1 times this binomial also will just keep the same. Then I'm going to bring down 1 plus cosine theta. Actually, let's put minus, so we'll have the same order on this side. And the 1 plus cosine theta. Again, since our denominators are the same, why not just do one combined fraction? So they both have 1 minus cosine theta, 1 plus cosine theta. And let's combine their numerators. Well, it's pretty simple. We'll combine like terms. The 1 plus another 1 is going to be a 2. And a cosine theta plus a negative cosine theta, these will end up becoming 0. All right, so you'd think we'd stop here, but what I want you to recall is that from day 2, hopefully you are starting to catch on when you see an A minus B and an A plus B situation, that is your difference of squares, okay? If you recall, I'm going to come right back over here. Remember, we talked about how these right here can be factored using the difference of squares formula. Let me recall up here. If you have two squared terms that are subtracting, you can factor it by writing it as A plus B, A minus B. Okay? So using that difference of squares formula, we know right here, these are subtracting, and they're both difference of squares, so I can rewrite sine squared theta as 1 plus cosine theta times 1 minus cosine theta. So sine squared theta is equal to 1 minus cosine squared theta, but sine squared theta is also equal to 1 plus cosine theta times 1 minus cosine theta, because this is just this rewritten, okay? Just like cosine squared theta would be the same as 1 plus sine theta times 1 minus sine theta. If we were to distribute this, you know, the entire time, for FOIL like you guys like to call it, you would end right back here. So why do I share all that? Well, 1 minus cosine theta and 1 plus cosine theta we just established is the same thing as sine squared theta. So I'm going to replace my denominator with sine squared theta. Because my goal is to simplify. But this can simplify one step further, because any number with sine theta in the denominator is going to be cosecant theta. The only difference is that was a 2. So 2 over sine squared theta is going to be 2 times cosecant squared theta. And of course, that's as far as we can go with that problem. All right, let's go to part D. And let me do this so that you don't get anything mixed up. And we can just not worry about this. This is just a repeat of part B. Okay, so we have tan theta minus secant squared theta over tangent theta. Again, fractions that are subtracting need common denominators. This is like saying tangent theta over 1. Our denominators are not the same. So let's get our lowest common denominator to be tangent theta. This one already fulfills it, so we don't even have to worry about doing anything to that second fraction. But let's go ahead and manipulate this first fraction into having a denominator of tangent theta. So we need to multiply top and bottom by tangent theta. And this one we're just going to bring it down. And we're basically multiplying top and bottom by 1. You don't have to write it down, but that's in essence what we're doing. We're multiplying it by 1. It doesn't need to change. So equals tangent squared theta over tangent theta minus secant squared theta over tangent theta. Now we have those denominators being the same, and that helps a lot. Tangent squared theta minus secant squared theta. Let's put it all over one denominator. There are different ways that you could continue this problem. I'm going to show you both methods, okay? So if we come over here and we see tangent squared theta minus secant squared theta, we can come over here and look around and see if we find that formula, okay? So tangent squared minus secant squared theta is not really showing up right here in this row. This is where the tangent squared and the secant squareds are. But we do notice that if we manipulated this one, we can get what we wanted. So for instance, if I moved this secant squared theta over to the other side by subtracting secant squared on both sides, right? So all we would have to do is replace tangent squared minus secant squared with -1 over, bring over the tangent theta. And we already know that the reciprocal of tangent theta is cotangent theta, except ours is a -1 over tangent theta, so that will make our cotangent negative. So that's one way you can work that problem. Okay, so I'm going to box this off because that's one way. I'm going to put a big or. I'm going to bring this step down here because there's some students that prefer the following way. So let me show you the other way. And you'll notice that both ways arrive to the same answer. Another way students did was they said, well, how about we just replace secant squared theta? Or how about we just replace tangent squared theta? It didn't matter which one they replaced, but let's do secant squared theta. Notice that secant squared theta is the same thing as 1 plus tangent squared theta. So what some students said was, well, let's just replace this one. Some students said they wanted to replace this one. But if you replace this one, I'm going to bring the tangent squared theta down, and this minus, and I'm going to replace secant squared theta with 1 plus tangent squared theta. That's what's in my formula sheet. Bring down the tangent theta. And if you notice, I'm going to have to distribute that 1. Okay, so you get tangent squared theta, a -1, a minus tangent squared theta. And I think you should be seeing what's happening here. Do you see it? Do you see how those ended up zeroing out and you ended up with -1 over tangent theta? Whoops, you can't see what I'm writing. I am so sorry. Let us review because you saw nothing. Really, really bad recording on my part. So let's do this again. Here was the original problem that I told you that I was going to show you the second method. I'm so sorry about that. All right, so what they did, let's review. This highlighted portion in pencil is what I'm replacing with this right here. Secant squared, so I'm going to highlight here. So I'm taking this highlighted portion, secant squared theta, and I'm substituting it with 1 plus tangent squared theta. So notice how I'm highlighting here and substituting it with its equivalent. And because there's a negative right on the outside, I said to multiply that negative to both those values. So bring down the tan squared, the -1, the minus tangent squared. And so these are zeroing out. So notice right here, you're just ending up with the exact thing that was right up here. So negative cotangent theta is the other way you could have done it. Okay? So hopefully you can see that there are different ways you can approach it sometimes. Alrighty. Let's go do our last problem for day 3 notes. Tangent theta over cotangent theta plus 1. So let's see. Let's rewrite this. Now, one way you can do it is you can break this up all into sine and cosine if you wanted to. Let's do this way first, and then I can show you another way. Let's leave tangent theta just as is, okay? Because I know I can rewrite cotangent theta as 1 over tangent theta. Okay? And in so doing, I know that I can multiply by the reciprocal. I keep the numerator. And this right here, remember, I'm going to multiply by the reciprocal of this one. And when I make the tangent go to the numerator, and I make the 1 go to the denominator, I'm going to bring this down, that ends up multiplying to be tangent squared plus 1. But you guys know that that is a Pythagorean identity of secant squared theta. Secant squared theta. Okay. Some students prefer breaking tangent and cotangent completely down into sine and cosine. So you can also do that. You'll notice that you still will get the same answer. You will still need to multiply by the reciprocal. So this will go here, this will go here. So this stays the same. This division right here becomes a multiplication, and then we rewrite this. This belongs now in the denominator, and that belongs in the numerator. Bring over the plus 1. That ends up being sine squared over cosine squared. And you'll see it's a little longer of a process, but what's important is that you arrive to the final answer. Sine over cosine is tangent, so sine squared over cosine squared is going to be tangent squared. And by then you notice that you are where we are. We arrive to the same destination as we did in the first step. Okay? All right, folks, that's the end of section 5.1. You are officially done with first semester of pre-calc. Thank you for watching.